Hello and welcome back to Friday Minis. Today, let's talk easing. Again, I'm sure we've talked about it before, but we're able to observe the effects of easing quite easily, right? If you're going to go from point A to point B in 1 second, there are a few ways of doing it, right? You can just chop it up into an equal amount of speed and it'll go linearly from point A to point B. If we use easing, it looks a little bit nicer because it accelerates and then decelerates when it gets there. So yeah, that's cool. Now, today we want to go beyond that a little. Today we want to look at the math that goes behind easing. Now, the context in which I'm going to use it in is the context that I've had to play with recently. The idea is this: we have a constant stream of values coming in. These values could be noisy because they could come from the real world. We use easing so as to basically smooth out the noise. To demonstrate what this looks like, I'm going to have this ball on screen. I'm going to use my mouse to, just move it around. And the idea is that the ball needs to eventually go to where my mouse is. Right now, it's set up so that it goes straight to, wherever my mouse is. As you can see, the effect is that, whatever noise doesn't get filtered at all, right? The motion of the ball exactly follows the motion of my mouse. So while the movement of the ball accurately represents the information that's coming in, it's not nice to look at, right? Because it's not smooth, it's jittery. Instead, I can use easing to tell the ball to, slowly approach where my cursor is. The effect looks something like this, right? It's very similar to the easing with seed. The ball takes a while to catch up to where my cursor actually is. So now that you understand the premise of what's happening, let's take a look at the code that actually drives this. The pertinent line of code looks something like this. Instead of updating the position of the ball directly to where my mouse position is, I will tell it to first calculate the difference. The difference is the distance between the ball and my cursor. If I were to increment the position of the ball by that amount, it would go straight to the cursor, right? It will go right there, and basically no matter how I move my mouse, it will always clear that distance and go exactly where it's supposed to go. Of course, that means that's as good as not doing easing at all. What's special is this additional number thrown in, also known as the easing factor. This is a number smaller than 1, which is multiplied into the difference. So the ball doesn't go the whole way, it only goes part of the way. In this case, it only covers 5% of the distance between itself and the cursor. That means, of course, that my current value, it's lagging behind, right? It's not actually updated to the final position. Now, remember, this thing works iteratively, right? So over time, new values are going to come in. And again, for each new value, the ball is only going to move 5% of the way. This means that if I move my mouse erratically, the ball is only going to be slightly influenced by that. However, any large movement that persists over a longer period of time will be faithfully captured. This essentially filters out the jittery noise. And that's the idea. That's the idea behind easing. Now, there's one last thing we didn't talk about, and that would be the easing factor. As you can imagine, the easing factor controls how far the ball lags behind. We saw how using an easing factor of 0.05 makes the ball very robust to noise, but in return, we lose responsiveness since it takes a very long time for the ball to converge upon the correct position. Higher easing factors mean better responsiveness, but less protection against noise, so there's a trade-off here. That, ladies and gentlemen, is easing in a nutshell. Now, what I've done is I've built this little app on the website. It gives you a feel of how easing factor affects the easing operation. Move the mouse left and right. The big yellow line shows you the value after easing. Higher easing factors are at the top, while lower ones are below, and that's why you'll observe the line lagging behind near the bottom. To look closer at lower easing factors, scroll down on your mouse wheel. You'll notice the axis ticks change on the graph. You're now basically zooming in on the lower part of the graph. Scroll up to undo this effect. That's all there is for this particular episode. Just a fun little experiment on how easing works, right? And a surprisingly simple way in which it actually works, right? Hopefully it makes sense to you now. That's all there is for this particular episode. Thank you very much for watching, and until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.